Hello there, and welcome to Midnight Geography. Tonight, we'll drift into the windswept expanses of Patagonia. Patagonia is where Earth stretches itself thin, a land pulled taut between two oceans, where distance becomes something you can touch. It's geography at its most elemental. Rock and ice engaged in eternal conversation. A place where the planet reveals its patience, its capacity for both desolation and abundance. If you enjoy these peaceful geographical explorations, consider liking and subscribing. It helps other curious minds find their way here too. But for now, let's begin. The Patagonian ice field spreads across the southern spine of the Andes like nature's own meditation on permanence and change. This vast expanse of frozen time, the world's second largest ice mass outside the polar regions, breathes with 48 major glaciers, each one a river of ice moving at its own contemplative pace. The ice here is ancient, compressed into shades of blue that exist nowhere else in nature, blues that have been waiting inside this ice for 10,000 years to meet the light. When you stand before this ice field, spanning its 16,000 square kilometers, you're witnessing water that fell as snow when humans were just learning to farm. The ice remembers everything and nothing, holding volcanic ash from eruptions centuries past, tiny bubbles of atmosphere from different eras, all locked in its crystalline memory. Some of these glaciers flow westward toward the Pacific, others east toward the Atlantic, as if the ice field itself cannot decide which ocean deserves its eventual gift of water. Rising from this frozen world, Cerro Torre presents itself as a granite needle piercing the Patagonian sky, though its true summit remains forever hidden. At just over 3,000 meters, it wears a peculiar crown, a mushroom-shaped formation of rime ice that builds and rebuilds itself with each passing storm. This ice mushroom, sometimes growing to 30 meters thick, forms when supercooled droplets in the clouds freeze instantly upon contact with the peak. The mountain creates its own weather, its own rules, standing in defiance of conventional mountaineering wisdom. Climbers speak of Cerro Torre with a mixture of reverence and bewilderment, for the mountain seems to actively resist human presence. The winds here don't simply blow, they sculpt, they carve, they transform. The rime ice makes the summit a constantly shifting target. What exists today may be gone tomorrow, rebuilt in a different form by the next storm. Local Tehuelche peoples called this peak Chalten, meaning smoking mountain, mistaking the constant plume of wind-blown snow for volcanic activity. Even now, on clear days, you can see this smoke streaming from the summit like the mountain's own flag of independence. The Valdez Peninsula extends into the Atlantic Ocean, like South America, reaching out to touch something it cannot quite grasp. This remarkable projection of land, connected to the mainland by an isthmus so narrow you can almost see both sides of the ocean simultaneously, harbors one of the continent's most intriguing geographical paradoxes. Here, at Laguna del Carbon, the land surrenders to the sea's memory, sinking to 105 meters below sea level, the lowest point in both South and North America. This depression, carved by ancient forces and maintained by the absence of drainage, collects salt and solitude in equal measure. The peninsula itself functions as a vast amphitheater for marine life, its curved shores and protected gulfs creating acoustic conditions that whales use for communication across vast distances. The land here is colored in shades of brown and gray that shift with the changing light, a palette that seems deliberately chosen to highlight the brilliant blues of the surrounding ocean. When southern right whales arrive here to calve, they return to the exact spots their mothers brought them, maintaining a geographical tradition that predates any human map of these waters. Torres del Paine's granite spires stand as monuments to patience, their formation a story that began 12 million years ago in the darkness beneath the Earth's surface. These towers didn't erupt or explode into being. Instead, they were born in silence, as magma pushed slowly upward, cooling into granite before ever reaching the surface. Then came the true architect, time itself, working with its assistance of wind, ice, and rain. Over millions of years, the softer sedimentary rock that once enclosed these granite cores was carved away, grain by grain, revealing these spectacular towers that now puncture the Patagonian sky at 2,500 meters. The three towers, Torre Sur, Torre Central, and Torre Norte, each possess their own character, their own angle of defiance against the elements. The granite here contains crystals of feldspar that catch the light at dawn and dusk, transforming the towers into briefly glowing sentinels. Between these towers flow hanging glaciers, remnants of the ice sheets that once covered all of Patagonia, now reduced to frozen waterfalls suspended in geological time. The town of El Chaltén exists as a curious footnote in the story of human geography, founded not from organic growth or economic opportunity, but from the abstract concept of sovereignty. Established in 1985, it represents one of Argentina's youngest settlements, placed strategically near a disputed border with Chile, like a chess piece on a geographical board. The town's existence is almost an afterthought to the landscape it inhabits, a small cluster of buildings that seem to apologize for interrupting the view of Cerro Fitzroy. With barely 600 permanent residents, El Chaltén swells and contracts with the seasons, breathing in thousands of visitors during summer months, then exhaling them as winter arrives. The streets here don't follow any urban planning logic, but instead curve and wind according to where the wind is least fierce, where the ground is most stable. Buildings huddle low against the earth, their roofs angled to shed not just rain, but the weight of possibility. The possibility that the next storm might simply decide to relocate them. This is a town that exists in negotiation with its environment, a place where human ambition has learned to speak in whispers. Lago General Carrera, or Lago Buenos Aires as it's known on the Argentine side, holds the distinction of being South America's deepest lake, plunging to depths that light cannot reach. This body of water, shared unequally between two nations, demonstrates how political boundaries become meaningless when faced with geological reality. The lake's most remarkable feature lies not in its impressive statistics, but in the marble caves carved into its Chilean shores, accessible only by boat or kayak. These caves, carved from solid marble peninsulas and islands, have been polished by 6,000 years of wave action into smooth, undulating chambers that seem to glow from within. The marble here contains swirls of mineral impurities that create patterns resembling frozen smoke or fossilized wind. When sunlight filters through the glacier-fed waters and reflects off these polished walls, the caves become natural cathedrals of blue light, each chamber offering its own variation on the theme of luminescence. The water itself, colored by glacial flour so fine it remains suspended indefinitely, creates a blue so intense that visitors often assume it must be artificial. The Patagonian steppe unfolds across 750,000 square kilometers, like Earth's experiment in minimalism. This vast expanse receives less rain than many deserts, yet it supports millions of sheep, each one a small white punctuation mark on an otherwise uninterrupted sentence of brown grassland. The steppe doesn't announce itself with dramatic features or obvious boundaries. Instead, It simply continues, kilometer after kilometer, until you forget that landscapes can be any other way. The wind here is not a visitor, but a permanent resident, having blown from west to east for so long that every plant grows with a permanent lean. Every rock formation shows the sculpting of aerial erosion. In some areas, the annual rainfall amounts to less than 200 millimeters, falling in brief, violent episodes that the hard-packed earth often refuses to absorb. Yet life persists here in forms adapted to scarcity. Plants with roots that dive deep into the earth searching for hidden moisture, animals that can survive on the memory of water. The sheep that graze these lands are descendants of flocks introduced in the late 1800s, their wool now carrying the lanolin-rich adaptation to Patagonian wind. Monte Fitzroy creates its own weather in real time, a 3,400-meter granite factory producing clouds, wind, and electrical phenomena that exist nowhere else in the region. The mountain stands like a Gothic cathedral designed by geology, its vertical walls and sharp summit creating aerodynamic conditions that transform ordinary weather into something otherworldly. When moist air from the Pacific encounters Fitzroy's eastern face, it's forced upward so violently that it forms lenticular clouds, smooth, lens-shaped formations that hover motionless despite winds that can exceed 150 kilometers per hour. These clouds, stacked sometimes 5 or 6 high, led early explorers to believe the mountain was volcanic, its summit perpetually wreathed in smoke. The indigenous Tehuelche people called it Chaltén, the smoking mountain. And even today, when conditions are right, the mountain appears to be exhaling great breaths of cloud that stream eastward for hundreds of kilometers. The granite here contains unusual quantities of magnetite, creating localized magnetic anomalies that affect compasses and potentially contribute to the frequency of lightning strikes that illuminate the peak during storms. The Carretera Austral represents one of the most ambitious acts of road building in the modern era, a 1,200-kilometer thread of gravel and determination threading through Chilean Patagonia. This highway, not completed until the year 2000, requires 17 ferry crossings to navigate the fjord-riddled coastline, making it less a road than a connect-the-dots puzzle drawn across impossible terrain. The construction of this route required workers to blast through solid rock, bridge glacial rivers that change course seasonally, and establish ferry connections across fjords where the ocean reaches deep into the continent's heart. In many places, the road clings to cliff faces so steep that engineers had to invent new techniques for anchoring the roadbed. Waterfalls cascade directly onto the pavement during spring melt, and landslides regularly erase sections that must be rebuilt with resigned patience. Villages along the route exist in isolation for months. When winter makes ferry crossings impossible, their residents living in a geographical parenthesis until spring returns. The road itself has become a kind of pilgrimage route for those seeking to understand what remoteness truly means in the 21st century. Perito Moreno Glacier performs a balancing act that defies the global trend of glacial retreat. While glaciers worldwide shrink and withdraw, Perito Moreno advances up to 2 meters daily at its center, while simultaneously calving massive ice blocks from its 5-kilometer-wide face. This creates an unusual equilibrium, a glacier that neither grows nor shrinks significantly, maintaining its position like a frozen dancer caught mid-step. The glacier descends from the southern Patagonian ice field through a valley that channels and compresses the ice, creating pressures so intense that the ice at the bottom becomes plastic, flowing like extremely slow water. When this river of ice meets Lago Argentino, it rises to heights of 70 meters above the water's surface, creating an ice cliff that regularly collapses in spectacular calvings. Every few years, the glacier's advance blocks a channel in the lake, causing water levels to rise until the pressure creates an ice tunnel that eventually collapses in one of nature's most dramatic performances. The ice here is so compressed that it appears blue-black in its depths, holding centuries of snowfall in crystalline formation. Ushuaia sits at the bottom of the world, or at least the bottom of the habitable world, a city whose existence seems to challenge the very concept of where humans should live. At 54 degrees south latitude, it's closer to Antarctica than to Buenos Aires, closer to penguins than to most of Argentina's population. The city occupies a narrow shelf between the Marshall Mountains and the Beagle Channel, squeezed into the only flat land available, spreading along the water rather than inland. Here, the trees grow flagged, their branches extending only to the east, sculpted by winds that never cease. The light here behaves differently, summer days stretching to 18 hours, while winter reduces daylight to a brief appearance between long darknesses. The city's architecture reflects this reality. Buildings painted in bright colors to combat the gray winters, windows facing north to capture whatever sun arrives. Ships bound for Antarctica provision here, making Ushuaia a last outpost of the familiar before venturing into the truly alien. The city's cemetery, climbing the hillside, offers the most spectacular views, as if the dead were given the best seats to watch the living's improbable persistence. Rio Santa Cruz flows from Lago Argentino to the Atlantic Ocean with remarkable lethargy, dropping only 180 meters across 385 kilometers. This river moves like liquid meditation, its gradient so gentle that wind can actually reverse its surface flow, while the deeper current continues seaward. The river carries the memories of glaciers in its turquoise color, suspended glacial flour that never quite settles, giving the water an opacity that hides its true depth. Along its banks, the geological history of Patagonia reveals itself in exposed layers, ancient lake beds, volcanic ash deposits, marine fossils from when this land lay beneath prehistoric seas. The river's meandering course has created a green corridor through the otherwise austere steppe, supporting forests of willows and southern beech that provide shelter for guanacos and condors. Charles Darwin navigated this river in 1834, noting its unusual color and the way it seemed to flow uphill due to optical illusions created by the surrounding landscape's subtle tilting. The Beagle Channel separates Tierra del Fuego's main island from the scattered archipelago to the south, a maritime corridor that formed when rising seas flooded a glacial valley 8,000 years ago. This channel, named after the ship that carried Darwin on his voyage of discovery, runs for 240 kilometers, connecting the Atlantic and Pacific Oceans through a passage so scenic that even hardened sailors speak of it in reverential tones. The channel's waters, deep and cold, create their own ecosystem, supporting forests of giant kelp that rise from depths of 40 meters to create underwater cathedrals. The mountains on either side plunge directly into the water, their slopes covered with southern beech forests that turn brilliant orange and red in autumn, creating reflections that double the world. Glaciers descend from the Darwin Cordillera to touch the channel's waters, creating a landscape where ice, forest, and sea exist in immediate proximity. The indigenous Yagan people navigated these waters for thousands of years in bark canoes, maintaining fires even while paddling. Their understanding of these waters so complete, they had different words for every type of wave. Punta Arenas experiences light like nowhere else in South America, its position at 53 degrees south, creating summer days that refuse to end and winter nights that refuse to begin. During the summer solstice, the city enjoys nearly 18 hours of daylight, the sun tracing a low arc across the northern sky, never rising high enough to create short shadows. In winter, the situation reverses, with a penis 7 hours separating sunrise from sunset, the sun barely clearing the horizon before beginning its descent. This extreme variation in daylight affects everything from human psychology to plant growth, creating a city that essentially experiences two different worlds each year. The architecture here has adapted to these conditions. Large windows facing north to capture winter light, small windows facing south to block summer's endless glare. The city's position on the Strait of Magellan means it also experiences wind as a constant companion. Buildings designed not for aesthetics, but for aerodynamics, their corners rounded to reduce wind resistance. Trees grow in protected courtyards, hidden from the wind that would otherwise prevent any vertical growth. The volcanic field of Polyike spreads across southern Patagonia like a frozen fireworks display, 468 volcanic cones scattered across 4,500 square kilometers. This field last erupted just 3,900 years ago, recent enough that the indigenous peoples of the region incorporated the event into their oral histories. The volcanic cones here are remarkably well preserved. The dry climate and lack of vegetation, meaning they appear almost as fresh as the day they cooled. The lava flows created a landscape of black rock that absorbs heat during the day and radiates it at night, creating microclimates that support unique ecosystems. In some places, the lava tubes have collapsed to create caves that were used by prehistoric humans, their walls still bearing paintings of guanacos and human hands. The contrast between the black volcanic rock and the tawny colors of the surrounding steppe creates a landscape that seems borrowed from another planet. When snow falls here, which happens rarely, it creates a brief black and white world that photographers describe as otherworldly. Lago Viedma holds icebergs year-round, floating sculptures of compressed time that have broken free from the Viedma Glacier. These icebergs, some as large as buildings, drift across the lake's surface, carrying embedded volcanic ash from eruptions that occurred 750 years ago. The ash creates dark stripes through the ice, a geological barcode that scientists can read to date the ice and trace its journey from snowfall to lake. The icebergs here don't simply melt, they rotate, flip, and occasionally explode from internal pressure, creating a constantly changing gallery of frozen forms. The lake itself, fed entirely by glacial melt, maintains a temperature just above freezing year-round, its waters so laden with glacial flour that visibility extends only centimeters below the surface. The southern shore of the lake is lined with fossilized forests, trees that grew here millions of years ago when Patagonia's climate was tropical, now turned to stone but still standing upright, creating the surreal scene of a stone forest watching ice float past. The Patagonian continental shelf extends eastward into the Atlantic Ocean like a hidden continent, stretching up to 850 kilometers from the visible coastline. This submarine plateau, one of the widest continental margins on Earth, creates unique conditions for marine life. The relatively shallow waters over the shelf, rarely exceeding 200 meters deep, allow sunlight to penetrate to the seafloor in many areas, supporting vast kelp forests and rich fishing grounds. The shelf's edge drops abruptly into the Argentine basin, creating upwelling currents that bring nutrients from the deep ocean to the surface. These currents support one of the most productive marine ecosystems in the southern hemisphere, feeding everything from microscopic plankton to southern right whales. The shelf itself is carved with submarine canyons, some extending hundreds of kilometers, carved by ancient rivers when sea levels were lower and this underwater plain was dry land. Seismic surveys have revealed buried river channels, fossil beaches, and even evidence of ancient human settlements now lying beneath hundreds of meters of water. Peninsula Mitre extends from Tierra del Fuego's eastern tip like a finger pointing toward the Falkland Islands. 2,400 square kilometers of land that remains one of Argentina's last unexplored regions. No roads reach this peninsula. No permanent settlements mark its coastlines. No regular flights pass overhead. The peninsula exists in a state of geographical isolation so complete that it has developed its own weather patterns, its own subspecies of plants, its own rhythms independent of human time. The coastline here is a maze of hidden coves, unnamed beaches, and rocky promontories that have claimed hundreds of ships over the centuries. The interior is a boggy mixture of moorland and stunted forest, where the ground itself seems uncertain, shifting between solid and liquid depending on recent rainfall. Archaeological evidence suggests indigenous peoples inhabited this peninsula for thousands of years, but their descendants were gone before any detailed recording of their culture could be made. Today, Peninsula Mitre stands as a reminder that even in our mapped and satellite photographed world, there remain places that exist outside the human narrative, places that continue their own stories without witness or documentation. The Chubut River Valley harbors one of Patagonia's most unlikely cultural treasures, a Welsh-speaking community established in 1865, maintaining their language and traditions 8,000 miles from Wales. The Welsh settlers arrived seeking religious and cultural freedom, choosing this remote valley precisely because it seemed too isolated for outside interference. They found a landscape that reminded them of home, not in its specifics, but in its feeling of existing at the edge of the possible. The colonists introduced irrigation to the valley, transforming sections of desert into productive farmland, and established a string of settlements with names like Trelew, Trevelyan, and Gaiman. Today, traditional Welsh tea houses still operate in these towns, serving bara brith and Welsh cakes to visitors who come seeking this geographical anomaly. The Welsh language survived here even as it declined in Wales itself, preserved by isolation and determination. Annual Eisteddfods, Welsh cultural festivals, still occur, with poetry and songs in Welsh echoing across a landscape that indigenous peoples called the Land of Fire. The geographical displacement has created subtle changes in the language itself, with Spanish and Tehuelche words creeping into the Welsh vocabulary. The Strait of Magellan stretches through the bottom of South America like a natural Panama Canal that nature carved herself, saving ships the treacherous journey around Cape Horn. This maritime corridor extends 570 kilometers, but performs a geographical magic trick at its narrowest point, squeezing down to just 2 kilometers wide at the Primera Angostura, or First Narrows. Here, the entire Pacific Ocean tries to exchange water with the Atlantic through a passage barely wider than some rivers. The tidal currents created by this compression reach 8 knots, strong enough that sailing ships would wait for days for the right conditions to pass through. The strait's waters remember every ship that has passed through since Magellan's discovery in 1520, from wooden galleons to modern cargo vessels. The channel follows an ancient fault line, a crack in the continent that the sea found and widened. Along its length, the water changes color multiple times, from Pacific blue to a murky green where glacial rivers enter, to an almost black shade in the deepest portions where 100-meter depths swallow light. Kelp forests grow so thick in some sections that early navigators mistook them for solid land. Patagonia's tablelands rise from the steppe like giant's stairs, flat-topped mesetas that tell the story of an ocean that vanished 60 million years ago. These elevated plains, now sitting 1,500 meters above sea level, were once the floor of a shallow sea, accumulating sediments layer by layer over millions of years. Then came the Great Lifting, as tectonic forces raised these ancient seafloors high into the air, transforming submarine plains into windswept plateaus. The mesetas preserve their oceanic memories in the form of marine fossils. Shells of creatures that never knew air now lie scattered across landscapes that never know moisture. The edges of these tablelands drop away in dramatic cliffs, exposing the geological layers like a cut cake, each stratum representing millions of years of accumulation. Wind erosion has carved fantastic formations into the cliff faces, creating natural amphitheaters and organ pipe formations that sing in the constant breeze. The flat tops of the mesetas create their own weather systems, forcing winds upward so violently that pilots avoid flying directly over them. From these heights, you can see the curve of the Earth, the horizon extending so far that weather systems appear as distant smudges of gray. El Calafate transforms seasonally like a breathing organism, its population swelling from 22,000 to over 85,000 during the brief Patagonian summer. This town exists primarily as a gateway to the glaciers, but it has developed its own peculiar rhythm, expanding and contracting with the tourist seasons like a civic tide. In winter, the town hibernates, its hotels shuttered, its restaurants reduced to serving locals who know each other by name. The streets become wide and empty, the wind having free rein to sculpt snowdrifts against doorways. Then summer arrives, and with it, a human migration that transforms every aspect of the town. Buildings that stood empty become bustling hotels. Residents rent spare rooms to strangers, and languages from every corner of the earth echo in streets designed for a much smaller population. The town's infrastructure stretches to accommodate this invasion. Water pressure drops during peak shower times. Electricity flickers when too many hotels run their heating simultaneously. Yet El Calafate has adapted to this schizophrenic existence. Its entire economy built around 3 months of chaos that fund 9 months of quietude. Lago Buenos Aires presents itself as a geographical paradox, a single body of water with 2 names, reflecting the arbitrary nature of political boundaries imposed on natural features. On the Argentine side, it's Lago Buenos Aires. Cross the invisible line in the water to Chile, and it becomes Lago General Carrera. This semantic confusion extends to the lake's statistics. It's either South America's 2nd or 4th largest lake, depending on which country's measurements you trust. The lake occupies a depression carved by ancient glaciers, its basin so deep that parts remain unmapped. The water here displays an unusual characteristic. It appears milky blue from glacial flour on the Chilean side where glaciers still feed it, but clearer on the Argentine side where the sediment has settled. The lake creates its own weather system, large enough to generate winds that can transform from calm to deadly in minutes. Indigenous peoples considered this lake sacred, believing it connected the underworld with the sky through its profound depth and reflective surface. Modern satellite imagery reveals underwater ridges and valleys that suggest this was once 2 separate lakes that merged as water levels rose. The southern Patagonian batholith extends along the Andes like the Earth's own backbone, a massive formation of granite that tells the story of an ocean that disappeared. This crystalline spine stretches 2,000 kilometers, formed when the Pacific seafloor dove beneath South America in a process called subduction. As the oceanic plate descended, it melted, creating vast chambers of magma that cooled slowly into granite. This process, occurring over millions of years, created the foundation upon which the Patagonian Andes would later rise. The batholith isn't visible as a single feature, but reveals itself in the granite peaks that puncture the landscape. Fitzroy, Cerro Torre, Paine Massif, each one a window into this massive underground formation. The granite here has a particular quality, containing crystals that formed under such specific conditions of temperature and pressure that geologists can read them like a historical record. In some places, xenoliths, fragments of older rock caught in the cooling granite, provide glimpses of what existed before this massive transformation. The batholith continues to influence the landscape today, its presence affecting everything from groundwater flow to the location of mineral deposits. Puerto Williams clings to existence on Navarino Island at nearly 55 degrees south latitude, a settlement that challenges the definition of a city. With fewer than 3,000 residents, it holds the title of world's southernmost city through a combination of determination and semantic flexibility. The settlement exists in a state of perpetual negotiation with its environment, every structure built with the understanding that the next storm might rearrange everything. The buildings here huddle together for protection, their roofs weighted down with rocks to prevent the wind from claiming them. The city's location south of the Beagle Channel means it exists in a different world from Ushuaia, its larger rival for the southernmost title. Here, the forests are more stunted, the mountains more immediate, the sense of existing at the edge of the habitable world more pronounced. The Chilean Navy maintains a presence here, their base providing the economic foundation that allows civilian life to persist. Children attending the world's southernmost school learn geography from a unique perspective. North is essentially everywhere, and the concept of going south means venturing into the Drake Passage toward Antarctica. The Patagonian pampas hold secrets in their circular depressions, features called bajos sin salida, lowlands without exit. These enclosed basins, scattered across the steppe like pockmarks, collect water that has nowhere to go, creating temporary oases in the desert landscape. During rare rain events, these depressions fill with water, transforming into shallow lakes that might persist for weeks or months before evaporation claims them. The water that collects here becomes increasingly saline as it evaporates, leaving behind rings of salt that mark former water levels like tree rings. These temporary wetlands support explosions of life. Dormant seeds germinate, amphibians emerge from underground hibernation, and birds arrive from hundreds of kilometers away, somehow aware that water has appeared. The bajos create microclimates in their depths, protected from wind and slightly more humid than the surrounding steppe. Archaeological evidence suggests indigenous peoples timed their movements to coincide with water in specific bajos, using them as reliable waypoints in an otherwise waterless landscape. Some of these depressions are so perfectly circular that early explorers believed they were meteor impact craters. Isla Grande de Tierra del Fuego spans nearly 48,000 square kilometers, divided between Chile and Argentina by a surveyor's straight line that ignores every natural feature. This arbitrary boundary, drawn in 1881 by diplomats who had never visited the island, runs from Cabo Espiritu Santo in the north to the Beagle Channel in the south, splitting mountains, bisecting rivers, and creating a geographical absurdity that persists to this day. The island itself is a world apart from mainland Patagonia, separated by the Strait of Magellan, but more profoundly divided by character. The northern portion resembles the Patagonian steppe, flat, windswept, and devoted to sheep. But traveling south, the landscape transforms dramatically. Mountains rising from nowhere, forests appearing as if summoned, the very atmosphere changing from horizontal to vertical. The island contains every type of geography Patagonia offers, compressed into a space smaller than Scotland. Ancient glaciers carved valleys that now hold pristine lakes, their waters so pure that scientists use them as baseline measurements for water quality studies. The name Land of Fire came from the countless fires Magellan observed, maintained by indigenous peoples who no longer exist. The Andes narrow dramatically as they traverse Patagonia, squeezed to a width of merely 150 kilometers compared to their 500-kilometer span in Bolivia. This compression occurs because the angle at which the oceanic plate slides beneath the continental plate changes, becoming steeper in the south. The result is mountains that rise more abruptly from the surrounding landscape, creating some of the most dramatic vertical relief on Earth. This narrow mountain belt concentrates geological forces into a smaller area, producing more intense folding, faulting, and volcanic activity. The compressed Andes also affect weather patterns differently, creating a more pronounced rain shadow effect that contributes to Patagonia's arid eastern slopes. The narrow width means glaciers flow shorter distances from accumulation to ablation zones, creating steeper, more dramatic ice falls. This geological compression has created perfect conditions for the formation of the granite spires that make Patagonian mountains famous. The limited width concentrated the intrusive igneous activity that formed these spectacular peaks. The narrowing also means that passes between Argentina and Chile are fewer and more dramatic, funneling both human and animal migration routes through specific corridors. Lake Argentino spreads across nearly 1,500 square kilometers like spilled milk, its surface a pale blue that comes from the glacial flour suspended in its waters. Despite its vast extent, the lake reaches depths of only 500 meters, making it relatively shallow for its size. Fed entirely by glacial meltwater, the lake serves as a collection basin for the southern Patagonian icefields runoff, its water level fluctuating with the seasonal pulse of ice melt. The lake's irregular shape, with multiple arms reaching into different valleys, creates a complex hydrology where waters of different temperatures and sediment loads meet, but don't immediately mix. In the Brazo Rico, the Perito Moreno Glacier periodically dams the water, creating a temporary lake within a lake that eventually breaks through in spectacular fashion. The lake's sediments preserve a detailed record of glacial advances and retreats, with core samples revealing climate variations stretching back tens of thousands of years. Islands within the lake support unique ecosystems, isolated long enough to develop distinct variations of common species. The indigenous Aonakenk people believed the lake was formed from the tears of a giant who mourned the loss of his beloved. Puerto Cristal stands abandoned on the Chilean coast, a ghost town that nature is slowly digesting. Established during the copper boom of the late 1800s, the town died suddenly in 1906 when the mines flooded, the water rising so quickly that workers left their tools where they dropped them. Now, more than a century later, southern beech forest creeps through the streets, roots buckling what remains of the pavement, branches growing through glassless windows. The industrial infrastructure remains partially intact, rusted ore carts on rails that lead nowhere, smelting furnaces gradually crumbling into geometric ruins, a pier extending into water that no ship has approached in living memory. The forest's reclamation follows a predictable pattern: mosses first, then ferns, then shrubs, and finally, the trees themselves, each stage preparing the ground for the next. Birds nest in the old church bell tower, and foxes den in what were once the mine offices. The town's cemetery, curiously, resists the forest's advance, its graves marked with headstones bearing names of immigrants who traveled halfway around the world to die in this remote place. Golfo San Jorge bites into Argentina's Atlantic coast, creating a vast, semicircular bay that has become one of South America's most important petroleum production zones. The Gulf's waters, averaging 90 meters deep, hide a submarine landscape of drilling platforms and pipelines that extract oil formed from marine organisms that lived here 100 million years ago. The petroleum deposits exist because this gulf was once much deeper, a basin where organic matter accumulated faster than it could decay. Over geological time, these deposits were buried, compressed, and cooked into oil that now powers 40% of Argentina's economy. The Gulf's shape creates unique oceanographic conditions. Currents spiral in a counterclockwise gyre that traps nutrients and creates one of the Atlantic's richest fishing grounds directly above the oil fields. This intersection of resources has created an uneasy coexistence between fishing fleets and petroleum platforms, each industry dependent on the Gulf's gifts, but potentially threatening to the other. From shore, on clear days, you can see the platforms dotting the horizon like a marine city, gas flares burning continuously like candles in a vast cathedral. The Patagonian wind deserves recognition as a geographical feature in its own right, a force so constant and powerful that it shapes everything it touches. Blowing from west to east at an average of 25 kilometers per hour, with gusts recorded at 180 kilometers per hour, this wind is born from the temperature differential between the Pacific Ocean and the continental interior. The wind doesn't simply blow across Patagonia. It sculpts it, carves it, polishes it. Every plant leans eastward, growing flags of vegetation on their lee sides. Rocks are hollowed into fantastic shapes called tafoni, their windward sides smooth as glass. The wind carries Patagonian soil across the Atlantic to fertilize the Amazon rainforest, an atmospheric river of nutrients flowing invisibly overhead. Animals have adapted to this constant force. Guanacos always graze facing into the wind to prevent dust from entering their nostrils, and birds have developed stronger flight muscles on one side of their bodies. The wind has its own vocabulary here: temporal, pampero, sudestada, each name describing a different mood, a different intensity, a different season of this eternal atmospheric river. Estancia Harborton maintains its operations on Tierra del Fuego as it has since 1886, the oldest continuously operating farm in Argentine Tierra del Fuego. Founded by Anglican missionary Thomas Bridges, the estancia represents one of the first permanent European settlements in these latitudes. The farm's buildings, constructed from local timber and corrugated iron shipped from England, have withstood more than a century of Fuegian storms. The estancia operates as a living museum of adaptation, its methods evolved through generations of trial and error in one of agriculture's most challenging environments. Sheep graze pastures that must be carefully managed to prevent overgrazing in a climate where grass grows slowly. The farm maintains gardens that shouldn't exist at this latitude, protected by windbreaks and microclimates created by strategic placement of buildings. The Bridges family cemetery overlooks the Beagle Channel, its weathered headstones marking generations who chose to make this remote place home. The estancia's workshop still contains tools brought from England in the 19th century, maintained and used because replacement parts are thousands of kilometers away. The Baker River flows through Chilean Patagonia with more force than any other river in Chile, draining an area larger than many European countries. Born from the confluence of rivers fed by the northern and southern Patagonian ice fields, the Baker carries the liquid history of glaciers toward the Pacific. The river's turquoise color comes from glacial flour so fine it remains suspended indefinitely, creating water that appears almost luminescent in sunlight. The Baker cuts through the Andes via a valley that predates the current mountains, a geographical anomaly where the river is older than the landscape it traverses. Rapids along its course create some of the most challenging whitewater in South America, where the compressed power of melting ice fields forces through narrow gorges. The river valley creates its own microclimate, supporting temperate rainforest in a region otherwise dominated by steppe and ice. Recent proposals to dam the Baker for hydroelectric power have sparked debates about the value of wild rivers in an energy-hungry world. The river's discharge varies dramatically with the seasons, swelling during summer melt to carry volumes that would fill a swimming pool every second. Isla de los Estados emerges from the Atlantic Ocean 29 kilometers east of Tierra del Fuego's tip, an island so remote and forbidding that it inspired Jules Verne's Lighthouse at the End of the World. The island stretches 65 kilometers long, but only 15 wide, a ridge of mountains rising directly from the sea. No permanent civilian population exists here. Only a small Argentine naval station that maintains the lighthouse that has warned ships away from these treacherous waters since 1884. The island's weather is so severe that trees grow horizontally, creating natural tunnels through which deer move protected from the wind. The surrounding waters, where the Atlantic and Pacific Oceans meet in chaos, have claimed more than 100 ships, earning the nickname Staten Island Graveyard. Archaeological evidence suggests the Yagan people visited seasonally, but even they, adapted to Tierra del Fuego's harsh conditions, didn't establish permanent settlements. The island's ecosystem has evolved in isolation, supporting several endemic species found nowhere else on Earth. Fog shrouds the island most days, lifting occasionally to reveal landscapes that seem designed to discourage human presence. The Deseado Massif holds some of South America's oldest secrets. Its rocks dated at 2.7 billion years old, formed when the Earth itself was young. This ancient core of continental crust somehow survived the geological violence that reshaped Patagonia repeatedly over eons. The massif's rocks predate complex life, formed when the atmosphere contained no oxygen, when the planet was an alien world unrecognizable to modern eyes. These ancient stones contain minerals that exist nowhere else in South America, crystals that formed under conditions that haven't existed for billions of years. The massif acts as a geological anchor, a stable point around which younger rocks have accumulated and eroded in endless cycles. Its presence affects everything from groundwater flow to the distribution of mineral deposits across central Patagonia. The weathering of these ancient rocks releases trace elements that create unique soil chemistry, supporting plant communities found nowhere else in the region. Indigenous peoples recognized the massif's significance, considering certain outcrops sacred, possibly sensing the profound age held within the stone. Modern uranium deposits in the region exist because of the massif's influence on groundwater chemistry over millions of years. Chile's northern Patagonian icefield spreads across 4,200 square kilometers, entirely within Chilean territory, a frozen kingdom feeding 28 major glaciers that flow toward both oceans. This icefield exists in complete isolation, separated from its southern counterpart by 100 kilometers of ice-free terrain. The isolation has created unique glaciological conditions. The ice here behaves differently, flows at different rates, responds to climate changes on different timescales. San Rafael Glacier, the icefield's most famous offspring, descends all the way to sea level at latitude 46 degrees south, the lowest latitude glacier meeting the ocean anywhere in the world. The ice field sits on a volcanic foundation, with geothermal heat affecting basal ice temperatures and flow rates in ways scientists are still trying to understand. Nunataks, peaks of rock protruding through the ice, create islands of life in the frozen expanse, supporting communities of plants that have survived ice ages on these rocky refuges. The ice field generates its own weather, creating a permanent zone of precipitation that maintains the ice even as global temperatures rise. Comodoro Rivadavia exists as a monument to serendipity, a city that owes its existence to a drilling error that struck oil instead of water. In 1907, a desperate search for fresh water to supply the small sheep shipping port led to drilling that, at 539 meters, hit petroleum instead. That accidental discovery transformed a forgotten coastal settlement into Argentina's oil capital. The city sprawls along the coast in defiance of topography, climbing hills and descending into valleys as dictated by the location of oil deposits rather than urban planning logic. The landscape around Comodoro is punctuated with thousands of pump jacks, their rhythmic nodding creating a mechanical forest that never sleeps. The city's architecture reflects its boomtown origins, utilitarian buildings designed for function rather than aesthetics, neighborhoods that grew organically around oil infrastructure. The constant smell of petroleum permeates everything, a perfume that residents no longer notice, but that marks visitors immediately. Beneath the city, a complex network of oil-bearing rock layers tells the story of ancient seas, prehistoric river deltas, and the slow transformation of life into energy. Cabo Froward extends into the Strait of Magellan, like South America's final gesture before surrendering to the sea. At 53 degrees and 54 minutes south, this promontory marks the continental mainland's southernmost point, though islands continue stepping stones toward Antarctica. A metal cross, replaced periodically as storms destroy each version, stands at the Cape's summit, visible to ships navigating the strait from 6 kilometers away. The Cape itself is a lesson in geological violence. Twisted rock layers show where tectonic forces crumpled the Earth's crust like paper. The winds here achieve a particular ferocity, funneled by the strait's configuration into speeds that can knock a person off their feet. No roads reach Cabo Froward. Arrival requires either a multi-day trek through forests and beaches or approach by sea through waters notorious for their unpredictability. The Cape divides weather systems, creating dramatically different conditions on either side, calm on one side, while storms rage on the other. From this point, every direction except south leads toward more hospitable lands, making Cabo Froward feel like standing at the edge of the habitable world. The Patagonian toothfish inhabits waters so deep and cold that humans rarely glimpse its world, living between 45 and 3,850 meters beneath the surface. This creature, marketed to the world as Chilean sea bass despite being neither a base nor exclusively Chilean, has evolved to thrive in near-freezing waters that would kill most fish. Its blood contains antifreeze proteins that prevent ice crystals from forming in its tissues, a biological miracle that allows it to swim through waters that hover just above freezing. The toothfish grows slowly in these dark depths, taking decades to reach maturity, accumulating years like tree rings in its ear bones. Commercial fishing vessels pursue these fish with lines that descend kilometers into the darkness, pulling them from depths where pressure would crush human lungs in seconds. The fish's name comes from its pronounced teeth, evolved to grip prey in the absolute darkness of the deep ocean. Around Patagonia's submarine mountains and valleys, toothfish patrol territories larger than cities, navigating by sensing electrical fields and pressure waves in water so dark that eyes become almost irrelevant. Route 40 stretches along Argentina's western edge like a spine of asphalt and gravel, running 5,194 kilometers from the Bolivian border to the southern reaches of Patagonia. This highway, one of the longest national routes in the world, passes through 20 provinces and every type of landscape Argentina possesses. In Patagonia, the road becomes an exercise in solitude, with sections where gas stations are separated by hundreds of kilometers of emptiness. The highway wasn't fully paved until recent decades, and long stretches remain gravel, where vehicles raise dust clouds visible for kilometers. Along its Patagonian length, the road offers a meditation on distance and isolation, passing through towns that exist solely because travelers need to stop somewhere. The route parallels the Andes at a respectful distance, close enough to see the mountains, but far enough to avoid their geological complications. Wind-bent signs mark distances to places that seem mythical in their remoteness. Drivers carry extra fuel, spare tires, and water, understanding that breakdown doesn't mean inconvenience, but potential danger. The road has developed its own culture, its own mythology, becoming a pilgrimage route for those seeking to understand Argentina's true scale. The Darwin Cordillera rises from Tierra del Fuego like a final rampart between South America and Antarctica, its glaciers performing a rare feat in the southern hemisphere, descending all the way to sea level. These tidewater glaciers, found nowhere else in South America outside this range, create a landscape where ice and ocean meet directly, without the interruption of land. The glaciers here calve icebergs directly into the Beagle Channel and other fjords, creating a geography more reminiscent of Alaska or Norway than typical South American landscapes. Named after the young naturalist who sailed these waters aboard HMS Beagle, the Cordillera preserves some of the most pristine glacial systems in the southern hemisphere. The mountains trap moisture from Pacific storms, converting it to snow that compresses into glaciers that flow like frozen rivers toward the sea. The sound of calving ice echoes through the fjords, sharp cracks followed by thunderous roars as apartment building-sized pieces of glacier crash into the water. These glaciers are remnants of the ice sheet that once covered all of Tierra del Fuego, survivors clinging to mountains high enough and cold enough to preserve them. Punta Tombo transforms each spring into one of nature's most remarkable gatherings, when 200,000 pairs of Magellanic penguins arrive to breed on just 3 kilometers of coastline. This narrow strip of land, protruding into the Atlantic Ocean, becomes a metropolis of penguins, their density exceeding that of most human cities. The penguins return to the exact same burrows year after year, navigating across thousands of kilometers of open ocean to find a specific hole in the ground. The colony's sound is overwhelming, a constant chorus of braying, trumpeting, and bill clapping that creates a wall of sound audible from a kilometer away. Beneath the sandy soil, a complex network of burrows extends like a subterranean city, some tunnels connecting multiple chambers, others dead-ending in abandoned attempts. The penguins have used this site for thousands of years, their guano slowly transforming the soil chemistry, creating conditions that paradoxically make the site even more suitable for burrowing. During peak season, the beach resembles a highway as thousands of penguins commute between ocean and nest, following invisible lanes that prevent collisions, maintaining a traffic pattern that would impress urban planners. Cerro Castillo's sedimentary layers read like pages in Earth's autobiography, each stratum recording a different chapter in Patagonia's history. Within these layers, preserved for 75 million years, lies Giganotosaurus carolinii, the largest carnivorous dinosaur ever discovered, a predator that makes Tyrannosaurus rex seem almost modest by comparison. This creature, measuring over 13 meters long, hunted across landscapes that bore no resemblance to modern Patagonia. Tropical forests where the Andes now stand, rivers flowing in directions that current geography makes impossible. The fossils here preserve not just bones, but entire ecosystems. Fossilized trees, ancient crocodiles, flying reptiles with wingspans exceeding small aircraft. The rock layers tell of catastrophic changes, volcanic eruptions that buried entire forests, floods that reoriented river systems, the slow rise of the Andes that transformed tropical lowlands into windswept steppes. Each fossil extracted from these cliffs requires careful documentation of its exact position, as the vertical sequence represents millions of years, and mixing layers would scramble time itself. The site continues to yield discoveries that reshape our understanding of Cretaceous life in the southern hemisphere. Chilean Patagonia's fjord region creates a labyrinth of water and land extending through 3,000 kilometers of navigable channels, though navigable requires generous interpretation. These waterways, carved by glaciers and drowned by rising seas, create a geography so complex that many channels remain uncharted, unnamed, unexplored. Ships navigating these waters follow routes established through centuries of trial and error, paths marked more by local knowledge than official charts. The fjords reach deep into the continent, some extending over 100 kilometers inland, bringing salt water to the foot of glaciers that remember when these valleys were filled with ice, not sea. The water in these channels often stratifies, with a layer of fresh water from glacial melt floating atop denser salt water, creating unusual optical effects where the boundary between layers is visible. Wildlife in the fjords has adapted to this mixing of waters: dolphins that hunt in fresh water, sea lions that travel far inland, forests that grow to the high tide line. The complexity of this coastline means that the straight line distance between 2 points might be 50 kilometers, while the navigable route extends to 300. Gobernador Gregores exists in a sphere of isolation remarkable even by Patagonian standards, sitting 300 kilometers from its nearest neighboring town across uninterrupted steppe. This distance isn't merely geographical, but psychological, creating a community that has developed its own rhythms independent of the outside world. The town's 2,000 residents have learned to be self-sufficient in ways that urban dwellers cannot imagine. Teachers who are also mechanics, doctors who double as veterinarians, shops that stock everything because the next opportunity to resupply might be weeks away. The single road connecting Gobernador Gregores to civilization is gravel, subject to closure by snow in winter and washouts during rare but intense rains. The town's children grow up with a different concept of space and community, where everyone knows everyone, where the arrival of strangers is an event, where the horizon is not blocked by buildings, but extends to the literal curvature of the earth. At night, with no light pollution for hundreds of kilometers, the sky reveals itself in its full glory, the Milky Way so bright it casts shadows. Laguna San Rafael exists as a testament to climate's power to reshape geography in human timescales. This 35-kilometer-long lake didn't exist 150 years ago, born when the San Rafael Glacier began its retreat, leaving behind a basin that Pacific waters quickly claimed. The lake continues to grow as the glacier retreats, each year adding meters to its length, creating new geography in real time. The water here displays an almost unnatural blue, colored by glacial flour so fine it acts more like a dye than sediment. Icebergs drift across the lake's surface, each one a fragment of compressed time, carrying within its structure air bubbles trapped when the snow fell centuries ago. The The lake's creation has altered local weather patterns, its water surface creating convection currents that didn't exist when glacier ice covered this area. Trees killed by the rising water stand as ghostly sentinels, their bleached trunks marking where forest became lake. Tour boats now navigate waters where indigenous peoples once hunted guanacos, a transformation so recent that some maps still show glacier where lake now exists. The Asen region sprawls across Chilean Patagonia with a population density that challenges the concept of human settlement, 0.9 people per square kilometer. This statistic translates into a reality where you could walk for days without encountering another human, where cellular signals are mythology, where the night sky has no competition from artificial light. The region's 100,000 square kilometers support fewer people than a small city, creating a social geography unlike anywhere else in the Western Hemisphere. Communities here develop intense bonds born from isolation and interdependence, where conflicts must be resolved because there's nowhere else to go. The landscape refuses to accommodate human convenience. Roads end abruptly at fjords, mountains block direct routes, ice fields create impassable barriers. This enforced isolation has preserved indigenous traditions and created unique cultural adaptations, including a dialect of Spanish influenced by the need to describe geographical features that don't exist elsewhere. The mail arrives by boat to many communities, weather permitting, and children in remote areas attend school by radio, their teachers' voices crackling across distances that would span entire European countries. Volcan Hudson erupted in August 1991 with a violence that reshaped Patagonian geography and economy in 48 hours. The eruption column rose 25 kilometers into the stratosphere, spreading ash across 100,000 square kilometers of territory. The ash fell like gray snow, accumulating meters deep in some areas, transforming summer pastures into lunar landscapes. Millions of sheep died, either suffocated by ash or starving when their food sources were buried. The Asen region's economy, dependent on wool production, collapsed overnight. Rivers ran gray for months as ash washed from hillsides, creating new sediment deltas that changed coastal geography. The eruption's ash contained microscopic glass shards that scarred lungs and destroyed engines, grounding aircraft across southern South America. Even now, more than 30 years later, rain events mobilize Hudson's ash, creating mud flows that reshape valleys. The volcano had been considered extinct, its previous eruption occurring before human memory. The 1991 eruption reminded Patagonians that their landscape remains violently active, that the mountains they see as permanent fixtures are merely temporary arrangements of restless rock. The Rio Gallegos estuary performs twice daily transformations that seem to defy physics, with tidal ranges reaching 13 meters, among the highest on Earth. During low tide, 40 square kilometers of mudflats emerge from beneath the water, creating temporary continents that exist for mere hours. These exposed flats become feeding grounds for millions of birds that have timed their migrations to coincide with these tidal extremes. The incoming tide doesn't creep, it charges, advancing across the flats at walking speed, transforming land to sea in minutes. The estuary's shape amplifies tidal forces, funneling the Atlantic Ocean's rise and fall into an increasingly narrow space until the water has nowhere to go but up. This dramatic tidal range has created unique adaptations in local organisms. Crabs that can survive hours of exposure, plants that tolerate regular saltwater immersion, fish that have learned to follow the tide's schedule. Historical accounts describe early settlers losing entire flocks of sheep to unexpected tidal surges, animals grazing on exposed flats suddenly surrounded by rising water. Modern aquaculture operations harness these tides, using the natural flushing to maintain water quality without pumps. Cueva de las Manos preserves humanity's ancient conversation with stone, its walls covered with 9,000-year-old hand stencils that seem to reach across millennia. The cave, actually a series of rock overhangs along the Pinturas River Canyon, contains over 2,000 handprints, mostly left hands, created by blowing pigment over hands pressed against the rock. The preservation is extraordinary. The colors remain vivid, protected by Patagonia's dry climate and the overhanging rock that shields them from rain. Beyond hands, the artists left images of guanacos, geometric patterns, and hunting scenes that provide glimpses into Paleolithic life in Patagonia. The pigments, red from iron oxide, white from kaolin, black from manganese, were sourced locally, ground and mixed with unknown binders that have proven remarkably durable. Multiple cultural phases are visible, with different artistic styles layered atop each other, suggesting the site's significance persisted across thousands of years and multiple peoples. The hand stencils create an unexpectedly emotional experience. These are not representations but actual traces, negative spaces where human hands blocked pigment, creating a direct physical connection to people who lived when Patagonia's climate and fauna were completely different. The southern Patagonian icefield hemorrhages ice at an alarming rate, losing approximately 20 cubic kilometers annually, enough water to supply Paris for 4 decades. This loss isn't uniform. Some glaciers retreat kilometers per decade, while others remain stable, creating a complex pattern of ice loss that scientists struggle to fully understand. The meltwater from this ice field feeds the largest rivers in southern Patagonia, their flow increasing measurably as the ice diminishes. Satellite imagery reveals the formation of new lakes where glaciers have retreated, bodies of water that didn't exist when current maps were drawn. The ice loss exposes land that hasn't seen sunlight in millennia, revealing preserved forests, archaeological sites, and geological features previously hidden beneath hundreds of meters of ice. This melting is creating new navigation routes through previously ice-blocked valleys, but also destabilizing mountain slopes previously held in place by glacial ice. The sound of the ice field's retreat is constant, creaking, groaning, occasional explosive cracks as crevasses form or seracs collapse. Local communities that have depended on glacial melt for freshwater are beginning to plan for a future when the ice is gone. Puerto Natales was founded in 1911 specifically to process and ship wool from the sheep estancias that were transforming Patagonia into a vast wool factory. The town's founders chose this location for its protected harbor on the Última Esperanza Sound, the Last Hope Sound, named by explorers who saw it as their final chance to find a passage to the Pacific. The original buildings were designed to withstand winds that regularly overturned vehicles, with rounded corners to reduce wind resistance and roofs weighted with local stone. The town's layout follows the wind's patterns, streets oriented to minimize exposure to the prevailing westerlies. Puerto Natales developed a unique architecture born from necessity. Buildings share walls for mutual support, windows face away from the wind, and doors are often placed in protected alcoves. The wool boom that created the town has long passed, but the infrastructure remains, repurposed now for tourism, but still bearing the marks of its industrial origins. Old wool warehouses have become hotels, their thick walls and small windows originally designed to protect wool bales now insulating guests from Patagonian weather. The Magellanic subpolar forests mark the absolute southern limit of tree growth outside Antarctica, ending definitively at 55 degrees south latitude. These forests, composed almost entirely of 3 species of southern beech, exist in conditions that would kill most trees: constant wind, minimal soil, temperatures that rarely exceed 10 degrees Celsius even in summer. The trees here grow slowly, adding perhaps a millimeter to their diameter annually, meaning a trunk thick as a human arm might be centuries old. The forest floor is a spongy mass of moss and decomposing wood, sometimes meters deep, creating a substrate that moves like a waterbed when walked upon. These forests have never known large herbivores, no deer, no rabbits, evolving in the absence of grazing pressure. The trees communicate through mycorrhizal networks, sharing nutrients and information through fungal connections that link the entire forest into a single superorganism. At the forest's southern edge, trees gradually shrink, becoming krummholz, twisted, ground-hugging forms that mark the absolute limit of arboreal ambition. Beyond this line, only cushion plants and mosses dare to photosynthesize. Lake Nahuel Huapi presents a geographical curiosity that seems designed to confuse cartographers. An island within a lake that contains another lake with its own island. Victoria Island, rising from Nahuel Huapi's waters, spans 200 square kilometers, large enough to support its own forests, mountains, and watersheds. Within Victoria Island lies another lake, and within that lake, another island, creating 3 nested levels of land and water like a geographical Russian doll. This recursive geography creates unique ecosystems at each level. The main lake supports one set of species. The island develops its own variations. The interior lake has different conditions still, and the innermost island represents a 4th level of isolation. Indigenous Mapuche peoples recognized this unusual geography's spiritual significance, conducting ceremonies on the innermost island that they believed existed simultaneously in multiple worlds. The formation of this nested system required a specific sequence of geological events: volcanic activity creating the initial depression, glacial action carving the interior lake, and precise water levels maintaining all 3 bodies of water. Modern satellite imagery reveals that this pattern continues at smaller scales, with pools on the innermost island that might contain their own tiny islands. The Colorado River traditionally marks Patagonia's northern boundary, though this designation carries more cultural than geographical significance. The river's headwaters originate 800 kilometers north of this supposed boundary, calling into question where Patagonia truly begins. The river itself seems uncertain, meandering through the landscape as if searching for its proper course, creating a green ribbon through otherwise arid lands. Where the Colorado meets the Atlantic Ocean, it builds and rebuilds its delta, depositing Andean sediments that traveled thousands of kilometers to reach the sea. The river's flow varies dramatically with snowmelt from the Andes, sometimes flooding vast areas, other times reducing to a series of connected pools. Ancient indigenous trade routes followed the Colorado, using it as a highway through otherwise inhospitable terrain. The river valley creates a microclimate that supports agriculture impossible in the surrounding desert, leading to irrigation projects that have transformed sections into productive farmland. Yet the river maintains its wild character, changing course during floods, creating oxbow lakes, and occasionally abandoning channels that communities had grown to depend upon. Peninsula Valdez hosts elephant seals that undertake vertical migrations as impressive as any horizontal journey, diving to 1,500 meters depth and holding their breath for up to 100 minutes. These massive pinnipeds, males weighing up to 4,000 kilograms, transform the peninsula's beaches into blubbery cities during breeding season. Their dives take them into the ocean's twilight zone, where pressure reaches 150 atmospheres and temperatures approach freezing. The seal's blood chemistry changes during these dives, shunting oxygen to critical organs while allowing peripheral tissues to function anaerobically. Satellite tags reveal their diving patterns, trace underwater canyons and mountains that no human has seen, navigating by sonar and sensitivity to magnetic fields. Between dives, they surface for just minutes, exhaling explosively and inhaling with equal violence before disappearing again into the depths. During breeding season, males fast for 3 months, living entirely off blubber reserves while fighting rivals and maintaining harems. The beaches where they breed show centuries of use: compressed sand, bones of seals that didn't survive, and wallows worn deep by countless generations. The ghost town of Epuyen stands as a monument to human gullibility and geological deception, established in 1905 when prospectors mistook pyrite for gold. The gold rush lasted only months, the time it took for someone to properly test the gleaming metal that had drawn hundreds to this remote valley. When news spread that the gold was merely fool's gold, the town emptied almost overnight, leaving behind buildings that seemed solid and permanent just days before. Now, more than a century later, Epuyen's remains tell a story of hope transformed into abandonment. The false gold still glitters in the surrounding rocks, catching sunlight in a way that explains the original confusion. Nature has begun reclaiming the town. Trees grow through floorboards, birds nest in rafters, and the pyrite that caused such excitement slowly oxidizes, creating rust-colored stains that mark where dreams died. The town's cemetery contains more graves from the few months of occupation than from the century since, victims of accidents, violence, and diseases that thrived in the unsanitary conditions of a boomtown that believed itself destined for greatness. Lago Posadas and Lago Pueyrredon exist as separated twins, two lakes that were once one until advancing glaciers divided them 12,000 years ago. The land bridge between them, created by glacial moraines, seems temporary even after 12 millennia, as if the lakes remember their unity and plot reunion. The two lakes maintain different water levels, different colors, different ecosystems, demonstrating how quickly isolation breeds divergence. Lago Posadas, the smaller sibling, has developed a unique chemistry from its limited watershed, while Pueyrredon, fed by larger glacial sources, maintains the turbid blue of glacial lakes. The indigenous peoples who witnessed this separation incorporated it into their oral histories, stories of the earth growing to separate the waters, of spirits that divided one great water into two. Sediment cores from both lakes show identical layers up to the point of separation, then diverge like a family tree splitting into branches. The narrow land bridge between them hosts unique species that exist nowhere else, evolved in the ecological tension between two bodies of water that were once one. The Tehuelche people traced routes across Patagonia that covered 1,000 kilometers seasonally, following guanaco migrations in an ancient choreography between predator and prey. These routes, invisible to European eyes but clear as highways to those who knew them, connected water sources, shelter sites, and seasonal hunting grounds in a network that spanned the entire region. The Tehuelche moved with the rhythms of the land, ascending to mountain valleys in summer when guanacos sought cool heights, descending to coastal plains in winter where maritime climates moderated temperatures. Their paths avoided the worst of Patagonian wind by following valleys and using ridgelines as shields. Along these routes, they left subtle markers, stones arranged in specific patterns, trees with particular bark scarring, caves with painted symbols that served as both spiritual sites and practical waypoints. The roots represented accumulated knowledge of countless generations, encoding information about where water remained during droughts, which passes stayed clear of snow, where guanacos gathered during mating season. Modern roads occasionally follow these ancient paths, engineers unknowingly tracing routes optimized over millennia. Archaeological evidence shows some camping sites were used continuously for over 4,000 years, temporary villages that appeared and disappeared with seasonal reliability. Cape Horn rises from the Drake Passage like Earth's final punctuation mark before Antarctica, a granite apostrophe 425 meters high marking where two great oceans converge in perpetual violence. This isn't merely where Atlantic meets Pacific, but where warm currents from the north collide with Antarctic waters, creating a confusion of waves that can reach 30 meters in height. The cape exists on Horn Island, the southernmost of the Hermit Islands, though from the sea it appears as a solitary monolith refusing to acknowledge neighbors. Sailors have feared this cape for 5 centuries, its waters claiming more than 800 ships and 10,000 lives. The winds here don't follow normal patterns, but create their own rules, accelerating around the cape in ways that transform sailing ships into uncontrollable projectiles. A lighthouse operates here, maintained by a Chilean naval family who live in possibly the world's most isolated posting. Their nearest neighbors, the penguins and albatrosses that somehow thrive in these conditions. The cape's name comes from the Dutch city of Hoorn, though its indigenous name, Kaikouche, better captures its nature, the end place. Villa O'Higgins marks where Chile's ambitions finally surrender to geography, the southern terminus of the Carretera Austral, where the road simply stops, defeated by ice fields and impassable mountains. This village of 530 souls exists at the edge of accessibility, reachable only 6 months of the year when winter snows don't block the single road. The settlement sits beside Lago O'Higgins, a lake so long it crosses into Argentina, where it becomes Lago San Martin, another body of water with an identity crisis. The village exists in a state of perpetual preparation for winter isolation, for the next supply delivery, for emergencies that would require evacuation by boat or helicopter, since the road might be closed. Buildings here are constructed with the understanding that replacement materials might not arrive for months, leading to an architecture of redundancy and repair. The surrounding landscape is so dramatic that residents have become numb to beauty that would stop visitors mid-stride. Glaciers visible from kitchen windows, condors circling above the school playground, forests that have never known an axe. Beyond Villa O'Higgins lies the southern Patagonian ice field, a wall of white that makes human settlement impossible. Spegazzini Glacier presents itself to visitors as a wall of ice that defies comprehension, terminating in cliffs that rise 135 meters above water level, the tallest accessible glacier face in South America. This frozen waterfall descends from the southern Patagonian ice field through a valley that compresses and pressurizes the ice until it achieves densities that transform its color from white through blue to an almost black depth. The glacier face isn't static, but constantly moving, advancing even as pieces calve away, creating a dynamic sculpture that never presents the same face twice. Boat captains approaching Spegazzini maintain respectful distances, knowing that calving events can create waves capable of capsizing vessels a kilometer away. The ice here makes sounds, not just the explosive cracks of calving, but constant smaller noises, creaks and groans and whispers, as billions of tons of frozen water adjust to pressure and temperature. The glacier has carved its valley so deeply that lake depth at the terminus exceeds 300 meters, meaning more glacier exists below water than above. Ancient moraines along the valley walls mark previous positions of the glacier, showing it once extended 40 kilometers further than today. The Patagonian Plateau tilts eastward at an angle of approximately 1 degree, a subtle inclination that determines the fate of every raindrop that falls across 700,000 square kilometers. This seemingly minor tilt means all major rivers flow toward the Atlantic rather than the much closer Pacific, water traveling hundreds of extra kilometers because of this gentle slope. The tilt isn't uniform but varies, creating areas where water becomes confused, forming closed basins and seasonal lakes that appear and disappear. This inclination resulted from the Andes rise, which didn't lift the land uniformly, but created a continental-scale seesaw with the mountains as fulcrum. The tilt affects more than just water. It influences wind patterns, animal migration routes, and even the distribution of human settlements, which cluster along rivers that wouldn't exist if the land tilted differently. Satellite measurements reveal the plateau is still adjusting, rising in some areas and subsiding in others, as the Earth's crust continues responding to Ice Age glaciers that melted 10,000 years ago. The tilt makes Patagonia a land that faces east, turned away from the Pacific's moisture, creating the rain shadow that defines its aridity. Seismometers positioned near Patagonian glaciers detect 5,000 icequakes annually, each one marking a moment when ice that seemed solid suddenly isn't. These seismic events, ranging from tiny adjustments to massive fractures, create a continuous symphony of breaking that human ears cannot detect, but sensitive instruments record faithfully. Unlike earthquakes that originate deep underground, icequakes happen at the surface or within the glaciers themselves, caused by stresses that build until ice catastrophically fails. Some icequakes result from crevasses opening, zipper-like fractures that can run for kilometers in seconds. Others occur at the glacier base where ice meets bedrock, stick-slip events where frozen rivers suddenly lurch forward. The largest ice quakes happen during calving events, when sections of glacier face collapse into lakes or seas, generating seismic waves that travel through bedrock for hundreds of kilometers. Scientists studying these signals have learned to read them like cardiograms of glacier health, detecting changes in flow rates, internal structure, and stability. The frequency of icequakes has increased dramatically in recent decades, the glaciers literally breaking apart more often as temperatures rise. The abandoned railway from Puerto Deseado to Las Heras stretches 283 kilometers through empty steppe, steel rails slowly being buried by sand and time. Built in the early 20th century to transport wool and minerals to the coast, the railway operated until 1978, when trucks finally proved more economical. Now the tracks remain like sutures across the landscape, too expensive to remove, too remote to scavenge. The wooden sleepers have weathered to gray, some burned by grass fires, others hollowed by insects that somehow survive in this treeless expanse. Station buildings stand at regular intervals, their walls still bearing schedule boards showing departure times for trains that haven't run for nearly 50 years. The rails themselves have become ecological corridors, their slight elevation creating windbreaks where plants grow taller, where small animals find shelter. In some sections, the rails sing in the wind, harmonic vibrations creating ethereal sounds that travel for kilometers. The railway's bridges still span dry arroyos that might carry water once a decade, over-engineered structures that will likely outlast everything else humans have built in this region. Local legends speak of ghost trains seen on moonlit nights, though these are likely mirages caused by heat shimmer on the metal rails. Isla Navarino, south of the Beagle Channel, supports the world's southernmost forests, composed entirely of 3 species of southern beech, that have learned to survive where survival seems impossible. These trees, Nothofagus pumilio, Nothofagus antarctica, and Nothofagus betuloides, grow in solidarity, their roots intertwined in the thin soil, sharing nutrients through fungal networks that make the forest essentially one organism. The trees here rarely exceed 10 meters in height, wind-pruned and cold-stunted, their growth rings so tight that a trunk the width of a human arm might be 3 centuries old. In autumn, these forests explode in colors that seem impossible at this latitude, brilliant oranges and reds that reflect in the channels and lakes, doubling the display. The forest floor is a spongy mass of moss that can be a meter deep, creating a substrate that moves like a living thing when walked upon. No large mammals inhabit these forests, no deer, no pumas, creating an ecosystem where birds and insects dominate. At the forest edge, trees gradually surrender to wind and cold, transforming into Krumholtz forms that crawl along the ground, marking the absolute southern limit of trees on Earth. The Rio Negro Valley cuts through northern Patagonia like a green miracle, its irrigated orchards producing 85% of Argentina's apples in a landscape that would otherwise support only sparse shrubs. This transformation began in the early 20th century when British engineers designed an irrigation system that turned desert into farmland almost overnight. The valley stretches for 300 kilometers, a narrow ribbon of green following the river's course through landscapes that receive less than 200 millimeters of rain annually. The contrast is striking. Step outside the irrigated zone and you're immediately in desert, the boundary between productive land and wasteland marked as clearly as if drawn with a ruler. The irrigation channels follow contours mapped with 19th century precision, gravity-fed systems that require minimal pumping. During spring bloom, the valley becomes a corridor of white and pink blossoms that seems to have been transported from another climate entirely. The apples grown here develop intense flavors, concentrated by the dry air and extreme temperature variations between day and night. Workers' settlements dot the valley at regular intervals, communities that exist entirely because of irrigation, places that would return to desert if the water stopped flowing. Monte San Lorenzo straddles the Argentine-Chilean border at 3,706 meters, Patagonia's second highest peak, yet virtually unknown outside climbing circles. The mountain remained unclimbed until 1943, not because of technical difficulty, but because of its remoteness. Reaching the base requires days of travel through unpopulated terrain. San Lorenzo creates its own weather system, its summit frequently wrapped in lenticular clouds that form and dissipate in hypnotic patterns. The mountain sits at the intersection of 2 climate zones, receiving Pacific moisture on its western slopes while its eastern faces overlook the arid steppe. This positioning creates dramatically different conditions on opposite sides of the same peak. Glaciers on one side, dry rock on the other. The border between Argentina and Chile runs exactly through the summit, though no marker exists at that altitude to acknowledge human political divisions. Glaciers flowing from San Lorenzo feed rivers that eventually reach both oceans, making it a continental divide in the truest sense. The mountain's remoteness means it hosts populations of huemul deer and condors that rarely encounter humans, existing in an ecosystem that functions much as it did before European arrival. The Kaweskar people navigated Patagonian channels in bark canoes that seem impossibly fragile for such hostile waters. Yet these vessels carried families through storms that modern boats would avoid. The canoes, built from southern beech bark sewn with whale sinew, were masterpieces of indigenous engineering, flexible enough to ride waves that would break rigid hulls. Most remarkably, the Kaweskar maintained fires burning continuously in their canoes, carried in clay-lined baskets, the flames never extinguished even while paddling through rain and spray. This perpetual fire served multiple purposes: warmth in the frigid channels, cooking, and perhaps most importantly, psychological comfort in a landscape that could kill within hours. The Kaweskar knew every channel, every current, every seasonal variation in these waters. Knowledge passed through generations in songs that served as both entertainment and navigation guides. They could predict weather changes by reading subtle signs: the way kelp moved, the color of water, the behavior of cormorants. Their language contained dozens of words for different types of water conditions, distinctions that Spanish and English cannot capture. Today, fewer than 8 native speakers of Kaweskar remain, their knowledge of these waters dying with them. Laguna Torre mirrors Cerro Torre so perfectly on calm days that local indigenous peoples believed the mountain existed both above and below ground, the lake serving as a portal between worlds. This belief seems less fanciful when you witness the reflection. The mountain's image in the lake appears more solid, more real than the actual peak, often hidden in clouds. The lake formed as Cerro Torre's glaciers retreated, leaving a basin that filled with meltwater of such purity that it acts as a perfect mirror. The water temperature never exceeds 4 degrees Celsius, fed entirely by glacial melt and snow. Icebergs regularly float across the lake's surface, each one a different shade of blue depending on its age and compression. The lake's depth remains unknown in places, its bottom obscured by glacial flour that creates an opacity preventing accurate soundings. During winter, the lake sometimes freezes completely, creating a platform of ice that mountaineers use to approach Cerro Torre's base. The surrounding moraines tell the story of the glacier's retreat, concentric ridges marking pause points in withdrawal, like rings in a tree trunk recording years of growth, but here, recording years of loss. The Patagonian coast hosts 17 species of marine mammals, creating one of the most diverse assemblages of sea life in any temperate zone. From the massive southern right whales to tiny commerson's dolphins that look like aquatic pandas, these waters support a richness that seems impossible given their cold temperatures and violent conditions. The diversity exists because of the unique oceanographic conditions: the mixing of Atlantic and Pacific waters, the extensive continental shelf, and the upwelling currents that bring nutrients from the deep. Each species has found its niche. Elephant seals dive deep for squid. Sea lions hunt in the kelp forests. Orcas patrol the beaches for unwary prey. The seasonal gatherings are spectacular. Thousands of sea lions breeding on remote beaches, pods of hundreds of dolphins moving like living rivers, whales congregating in protected bays. Some species, like the southern right whale, use Patagonian waters as nurseries, their calves' first experiences of the ocean occurring in these austere waters. The indigenous peoples of the coast developed hunting techniques specific to each species, understanding their behaviors and seasons with precision that modern marine biologists still struggle to match. Puerto San Julián carries historical weight disproportionate to its current modest size, the place where Magellan wintered in 1520 during his circumnavigation, where European and Patagonian histories first intensely collided. The bay here provided shelter from Atlantic storms, but Magellan's stay was marked by mutiny, executions, and first contact with the Tehuelche people, whom the Europeans called Patagones, big feet, giving the region its name. Today, anchor scars on coastal rocks remain from 16th century vessels, grooves worn into stone by iron anchors during that historic winter. The bay's shape creates unusual acoustic properties. Sounds carry across the water with clarity that seems supernatural, perhaps explaining why Magellan's crew reported hearing giant voices from shore. The port town that eventually developed here never achieved the greatness its historical significance might suggest, remaining a modest fishing community where history feels more present than future. Francis Drake arrived here 58 years after Magellan, executing his own mutineer on the same gibbet Magellan had built, as if the place itself demanded blood from those who would round the continent. The sediments in the bay contain unusual concentrations of 16th century artifacts, more than at any other single site on the Patagonian coast. The Uppsala Glacier has retreated 3 kilometers since 1995, a withdrawal so rapid that maps become obsolete before they're printed. This retreat has created a new lake covering 15 square kilometers, water where ice stood just decades ago. The glacier, once Patagonia's largest, is disintegrating in real time, its terminus a chaos of seracs and crevasses that speak of ice under stress. The retreat isn't uniform, but happens in catastrophic events, massive calvings that can release cubic kilometers of ice in hours. The newly exposed land reveals perfectly preserved forests that the advancing glacier overrode centuries ago, trees still standing but dead, their wood preserved by the cold. These ghost forests provide precise dating for the glacier's previous advance, tree rings telling exactly when the ice arrived. The lake formed by Uppsala's retreat has unusual properties. Its water is stratified by temperature and sediment load, creating distinct layers that don't mix. Icebergs from the glacier can float for months in this lake, some large enough to create their own weather patterns, cold air flowing off their surfaces like invisible waterfalls. Satellite monitoring shows the retreat accelerating, each year's loss exceeding the previous, a trajectory that suggests the glacier might disappear entirely within decades. Patagonia's wool production peaked in 1950 at 50 million kilograms annually, a yield that transformed the region into one vast sheep ranch. This golden age of wool created enormous wealth, funding mansions in Buenos Aires and London, built by estancia owners who might visit their Patagonian properties once a year. The landscape still bears scars from this era. Millions of kilometers of fence lines dividing the steppe into rectangles, many now maintaining boundaries that no longer matter. The decline to today's 12 million kilograms reflects multiple factors: synthetic fibers, changing fashion, soil exhaustion from overgrazing. Abandoned shearing sheds dot the landscape, massive structures that once processed thousands of sheep now serving as windbreaks for guanacos. The social structure created by the wool boom persists in modified form. The distinction between estancia owner and worker, the seasonal rhythms of shearing and lambing, the specialized vocabulary of sheep ranching that includes words borrowed from Scottish shepherds, Basque migrants, and indigenous languages. Some estancias have converted to tourism, their shearing sheds becoming museums, but most simply continue at reduced scale, maintaining traditions that no longer make economic sense. The Chonos Archipelago fragments the Chilean coast into 1,048 identified islands, though naval estimates suggest 5,000 more remain unmapped, unnamed, unknown. This maze of land and water extends for hundreds of kilometers, creating a geography so complex that even satellite imagery struggles to distinguish between island and peninsula, channel and bay. The archipelago exists in near-permanent rain, receiving over 4,000 millimeters annually, creating a temperate rainforest that grows to the high tide line. Many islands have never been explored, their interiors as unknown as when Darwin sailed past in the 1830s. The channels between islands create their own currents, tidal races that can exceed 10 knots, making navigation dangerous even for modern vessels. Some islands appear and disappear with tides. Others are so similar that sailors have been known to anchor at the wrong island and not realize their error for days. The indigenous Chono people, after whom the archipelago is named, navigated these waters for thousands of years before disappearing in the 18th century, taking their knowledge of safe passages and seasonal variations with them. Modern fishing boats follow routes established through trial and error, paths marked by GPS coordinates rather than the mental maps the Chono must have carried. Fossil forests near Sarmiento stand as monuments to Patagonia's dramatically different past, petrified trees 65 million years old, some still upright after mineralization transformed wood to stone. These trees grew when Patagonia was tropical, when dinosaurs browsed their leaves, when the Andes hadn't yet risen to block Pacific moisture. The fossilization process replaced organic material atom by atom with minerals, preserving cellular structure so perfectly that growth rings can still be counted. Some trunks measure over 3 meters in diameter, suggesting trees that towered over landscapes unrecognizable today. The fossil forest extends for kilometers, thousands of stone trees scattered across badlands that erosion has carved into fantastic shapes. The contrast between these tropical fossils and the current desert environment creates a cognitive dissonance. The mind struggles to reconcile evidence of rainforest with the sparse shrubs that now represent the area's only vegetation. Walking among these stone trees feels like visiting an alien planet that happens to occupy the same coordinates as Earth. The minerals that replaced the wood created patterns of color: reds from iron, greens from copper, blacks from manganese, making each fossilized trunk a unique geological artwork. The Atlantic coast of Patagonia descends to the sea in a series of stepped terraces, each one marking an ancient sea level from different geological epochs. These terraces, sometimes called marine benches, can extend for hundreds of kilometers, creating a landscape that looks like giant stairs carved into the continent. Each terrace preserves evidence of its time underwater: marine fossils, beach pebbles, wave-cut notches in cliffs. The terraces tell the story of sea levels that have fluctuated by hundreds of meters over millions of years, rising and falling with ice ages, tectonic movements, and changes in ocean basin geometry. Some terraces sit 300 meters above current sea level, their surfaces still bearing the rounded cobbles of ancient beaches. The stepping creates unique ecosystems at each level, with different vegetation communities adapted to the varying distances from the sea. Archaeological sites cluster on certain terraces, suggesting indigenous peoples recognized and utilized these natural platforms. From the air, the terraces create a striped pattern along the coast, each stripe a different chapter in the story of land and sea, negotiating their boundary over geological time. Cerro Torres summit was first definitively reached in 1974, though an earlier claim from 1959 remains one of mountaineering's most controversial disputes. Cesare Maestri claimed to have reached the summit with Tony Egger, but Egger died during the descent, taking with him the camera that supposedly contained summit photos. Maestri's description of the route contained inconsistencies, and no trace of his claimed equipment was found by later climbers. The controversy divided the climbing community for decades, with some defending Maestri's achievement and others calling it mountaineering's greatest fraud. Maestri returned in 1970 with a compressed air drill, creating a bolt ladder up the mountain's east face in what many considered an act of revenge against his critics. This compressor route itself became controversial, seen by purists as defacing the mountain. The first undisputed ascent in 1974 via a different route found no evidence of Maestry's claimed 1959 summit visit. The controversy reveals something deeper about human nature, our need to claim first ascents, to plant flags, to prove ourselves against geology's indifference. Cerro Torre remains aloof from human disputes, its summit still defended by the rime ice mushroom that makes every ascent uncertain until the final moments. The Futaleufu River drops 280 meters over just 100 kilometers, creating rapids so violent they exist nowhere else in the southern hemisphere with such concentrated intensity. The river's name means Big River in Mapudungun, though this translation fails to capture the violence of water that transforms from placid lake outlet to liquid chaos. The rapids here achieve Class 5 designation, the highest level before a river becomes technically unnavigable, where water moves with such force it creates its own weather. Spray that rises like rain falling upward, hydraulics that can trap objects in perpetual tumbling. The river's turquoise color comes from glacial flour so fine it acts as a natural filter, creating water that appears illuminated from within. Kayakers who navigate these rapids describe time dilation, moments stretching as the brain processes information at speeds normally reserved for life-threatening situations. The river carved its canyon when glaciers blocked other drainage routes, forcing water to cut through solid granite, creating a gorge where walls rise directly from churning water. The sound of the Futaleufu is omnipresent in its valley, not the gentle babble of streams, but a deep thrumming that vibrates through bedrock, a bass note felt as much as heard. Shell middens along Patagonia's coast rise 8 meters high in places, monuments built from millions of discarded shells accumulated over 6,000 years of continuous human habitation. These aren't random piles but structured deposits, each layer representing different periods, different peoples, different dietary preferences readable in the types of shells present. The middens contain more than shells: fish bones, stone tools, charcoal from ancient fires, and occasionally human burials, making them archives of pre-European life. The shells themselves have transformed over time, lower layers compressed into near concrete, creating structures solid enough that early European settlers quarried them for building material. Chemical analysis of shells from different layers reveals changes in ocean temperature and salinity over millennia, making middens climate records as well as archaeological sites. Some middens show evidence of seasonal use, with certain shellfish species appearing only in layers corresponding to specific times of year. The indigenous peoples who created these middens understood sustainable harvesting. Shell sizes remain consistent through thousands of years of layers, indicating populations were never overexploited. Walking over a midden produces a distinctive crunching sound, footsteps breaking shells that have waited centuries for this moment of final fragmentation. Monte Pisas Glacier sits at 6,700 meters elevation in northern Patagonia, claiming the distinction of Earth's highest glacier outside the Himalayan region. This glacier shouldn't exist according to conventional understanding. It survives at latitudes where such altitude typically means desert conditions. The glacier persists through a delicate balance of factors: Pacific moisture that occasionally breaches the Andean barrier, temperatures cold enough to preserve snow despite intense solar radiation, and topography that shelters ice from sublimation. The glacier is small, more an ice cap than a flowing glacier, clinging to Pisas's summit like frozen armor. Climbers reaching these heights describe a landscape more lunar than terrestrial: black volcanic rock protruding through white ice under skies so deep blue they appear purple. The air at this elevation contains 40% of sea level oxygen, making every movement deliberate, every breath conscious. The glacier's ice cores contain volcanic ash from eruptions across the Pacific, transported by jet stream winds that circle the globe at these altitudes. Climate change threatens this unlikely glacier more than lower elevation ice. Here, a temperature rise of even 1 degree could tip the balance from accumulation to ablation, erasing ice that has persisted since before human civilization began. Ratatili exists in constant negotiation with sand dunes that migrate 15 meters annually, a town built on shifting foundations that require continuous adaptation. The dunes move with prevailing winds, burying roads that must be excavated, filling gardens that must be cleared, creating a Sisyphean battle between human infrastructure and mobile geology. The town's residents have developed a unique relationship with sand. They know its moods, can predict its movements, understand that fighting it directly is futile. Buildings are designed with sand accumulation in mind, with doors that can function even when partially buried, windows that seal against grains finer than flour. The main coastal road requires realignment every few years as dunes advance or retreat, its path marked more by current necessity than planning. The sand here contains unusual minerals that give it a slight pink tinge in certain light, making the dunes appear to blush at sunset. Children growing up in Ratatili learn to read the dunes like weather, knowing which formations indicate imminent movement, which hollows will fill first during storms. The town's cemetery shows the sand's ultimate victory, older graves slowly disappearing beneath advancing dunes, headstones becoming shorter each year. Patagonian rivers collectively deliver 38 million tons of sediment annually to the Atlantic Ocean, creating underwater canyons that extend 300 kilometers from shore. This sediment, eroded from the Andes and carried across the continent, doesn't simply disappear into the ocean, but creates submarine landscapes as dramatic as any on land. The sediment flows carve canyons in the continental shelf, channels that funnel nutrients from shallow to deep waters, creating ecological highways for marine life. These underwater canyons can be deeper than their terrestrial counterparts, with walls that would dwarf the Grand Canyon if exposed to air. The sediment itself tells Patagonia's story: volcanic ash from eruptions, glacial flour from ice-grinding rock, organic matter from the sparse vegetation. During rare submarine avalanches, millions of tons of accumulated sediment cascade down canyon walls in events that generate tsunamis and reshape seafloor geography in hours. The canyons create upwelling currents that bring deep ocean nutrients to the surface, supporting the rich fisheries that sustain Patagonia's coastal communities. Submarine robots exploring these canyons have discovered ecosystems that exist nowhere else. Communities of organisms adapted to life in permanent darkness, sustained by the constant rain of sediment from above. Wild horses roamed Patagonia for 400 years, descendants of Spanish stock abandoned in 1540 when early colonization attempts failed. These horses, known as baguales, evolved into hardy creatures bearing little resemblance to their domestic ancestors. Shorter, stockier, with thick coats and hooves adapted to rocky terrain. They survived temperatures that would kill domestic horses, found water in places that seemed absolutely dry, formed complex social structures that allowed herds to thrive in one of Earth's most challenging environments. The horses became part of Patagonia's ecology, their grazing patterns affecting plant communities, their trails becoming wildlife corridors, their presence so established that they seemed native. Indigenous peoples incorporated these horses into their culture, developing riding and hunting techniques that transformed their society. The campaign to eliminate wild horses in the 1960s was driven by sheep ranchers who saw them as competition for grazing land. The elimination was thorough: aerial hunting, poisoned water sources, systematic roundups that removed tens of thousands of animals. Today, only scattered bones in remote valleys mark where wild horses once galloped, their 4-century presence erased in less than a decade, leaving Patagonia slightly emptier, slightly less wild. Glacier Grande spreads across 32 square kilometers of Tierra del Fuego, a massive ice field that somehow lacks an official name on Chilean maps, despite being one of the region's largest glaciers. This cartographic oversight speaks to the remoteness of the area. So few people have visited that no one has successfully advocated for formal recognition. The glacier flows from the Darwin Cordillera toward the Beagle Channel, but never reaches the sea, ending in a chaotic terminus of crevasses and seracs. Indigenous peoples had names for this glacier in languages now extinct, words that described its behavior, its moods, its relationship to weather and seasons. The glacier feeds several rivers that have names, creates lakes that appear on maps, yet itself remains anonymous, identified only by coordinates or informal descriptors. This namelessness grants it a certain mystique. Unmapped places feel wilder, less claimed by human ambition. Scientists studying the glacier must reference it awkwardly in papers, using phrases like the large unnamed glacier at coordinates. The ice itself is indifferent to its anonymity, continuing its slow flow, its patient erosion, its gradual retreat that may see it disappear before it ever receives official recognition. The submarine canyon off Peninsula Valdez plunges 1,800 meters below sea level, creating an underwater abyss deeper than the Grand Canyon. This hidden chasm exists just kilometers from where tourists photograph whales, its depths unknown to most who visit the peninsula. The canyon formed through a combination of river erosion when sea levels were lower and ongoing submarine currents that continue to carve its walls. The pressure at the canyon's bottom exceeds 180 atmospheres, creating an environment as alien as space. Sperm whales dive into this canyon to hunt giant squid in battles no human has witnessed, struggles between giants in perpetual darkness. The canyon walls host communities of deep-sea corals and sponges that filter feed on organic matter falling from above, creating underwater gardens that exist without sunlight. Submarine landslides occasionally reshape the canyon, millions of tons of sediment cascading into the depths in events that register on seismometers hundreds of kilometers away. The canyon affects ocean currents, creating upwellings that bring nutrients from the deep, supporting the rich marine ecosystem that makes Peninsula Valdez famous. Research submarines have explored only fractions of the canyon, each dive revealing new species, new geological features, new questions about this hidden landscape. Wind erosion removes 75 tons of soil per hectare annually from unprotected surfaces in Patagonia, a loss that represents millions of years of soil formation disappearing in human timescales. This erosion isn't gradual, but happens in dramatic events, windstorms that darken the sky with suspended soil, creating dust clouds visible from space. The soil doesn't simply vanish, but travels vast distances, Patagonian dust fertilizing Amazon rainforests, settling on Antarctic ice, circling the globe in atmospheric rivers of sediment. Where vegetation has been removed by overgrazing, erosion accelerates exponentially, creating badlands where bedrock emerges through thinning soil like bones through skin. The wind sorts particles by size as it transports them, leaving behind lag gravels of stones too heavy to move, creating desert pavements that protect underlying soil until the next disturbance. Fence lines show erosion's progress. Posts that once stood at ground level now rise on pedestals of protected soil, while adjacent areas have lowered by meters. Some estancias have lost entire paddocks to erosion, productive land transformed to moonscape in single generations. The sound of erosion is distinctive, a hissing as millions of particles collide, a pattering against windows that sounds like rain, but leaves everything covered in dust. Porvenir emerged on Tierra del Fuego during the 1880s gold rush, when nuggets weighing 600 grams were discovered in streams, triggering a stampede to the end of the world. The town's name means future in Spanish, reflecting the optimism of those who believed they'd found the next California. The gold was alluvial, eroded from the Darwin Cordillera and concentrated in stream gravels, accessible to anyone with a pan and patience. The largest nuggets were found in the first years, some so large they were initially mistaken for pyrite, because gold shouldn't occur in such quantities. The rush brought fortune seekers from Croatia, Scotland, China, and dozens of other nations, creating a polyglot community at the edge of habitability. The gold played out within decades, but Porvenir persisted, transforming from mining camp to administrative center. Buildings from the gold rush still stand, their architecture a mixture of styles reflecting their builders' origins: Croatian stone masonry, Scottish timber framing, Chinese decorative elements. The cemetery tells the rush's darker story: graves of those who died from exposure, violence, disease, and disappointment. Headstones in a dozen languages marking lives that ended far from home. Lago Cardiel occupies an enclosed basin with no outlet, its level rising and falling over centuries in response to climate patterns that operate on timescales beyond human perception. The lake can fluctuate 20 meters between extremes, alternately flooding and exposing vast areas of lakebed. These fluctuations leave distinct shorelines carved into surrounding hillsides, like bathtub rings marking different fill levels. During low periods, the exposed lakebed becomes colonized by specialized plants that can tolerate salt and irregular flooding, creating temporary grasslands that disappear when water returns. The lake's isolation means its chemistry differs from all other Patagonian lakes: higher salinity, unique mineral content, microscopic life found nowhere else. Indigenous oral histories describe the lake at different levels, stories that correlate with geological evidence of past configurations. The lake responds to rainfall patterns hundreds of kilometers away, its watershed collecting water that may take years to reach the basin. Fish populations in Lago Cardiel have evolved in isolation, developing characteristics that differ from the same species in connected water bodies. The lake's level serves as a long-term climate indicator, its rises and falls recording wet and dry periods that tree rings and ice cores corroborate. The Giannamini National Reserve displays rocks colored in 7 distinct shades, a geological rainbow created by different mineral oxidation processes over millions of years. Iron creates reds and oranges, copper produces greens and blues, manganese adds purples and blacks, while sulfur contributes yellows. These colors aren't painted on, but penetrate deep into the rock, the result of chemical reactions that occurred under specific conditions of temperature, pressure, and groundwater chemistry. The colored rocks are sedimentary, laid down in ancient lakes and rivers when this area's climate was entirely different. Each color band represents different environmental conditions. Red layers indicate oxidizing conditions. Green suggests reducing environments. Purple marks volcanic ash falls. The colors intensify after rain, water bringing out hues that seem muted when dry. Indigenous peoples considered these rocks sacred, believing each color possessed different properties, using them for pigments in ceremonial paintings. Modern artists travel here to study colors that can't be replicated artificially, shades that exist because of unique geological circumstances. The rocks weather differently depending on their composition, creating a landscape of colored pinnacles, arches, and balanced rocks that seems designed by an artist working in stone. Southern right whales navigate back to the exact Patagonian bays where their mothers brought them as calves, a pattern maintained for at least 40 generations that we can document. This fidelity to specific locations means individual bays host genetic lineages of whales, families that have used the same waters for centuries. The whales remember underwater topography, current patterns, acoustic properties that make each bay unique. Mothers teach calves the route during their first migration, a journey of thousands of kilometers that the calf will repeat throughout its 70-year lifespan. The whales arrive with precision timing, appearing in bays within days of the same date annually, their internal calendars synchronized to rhythms we don't fully understand. Each bay offers slightly different conditions, some better for nursing, others for mating, some providing protection from orcas. The whales communicate across vast distances using low-frequency calls that travel through the water and possibly through the seafloor itself. Scars on returning whales tell stories of encounters with ships, orcas, and unknown hazards in distant seas, yet they return, drawn by inherited memory to waters their ancestors knew. The Deseado River disappears into limestone caves for 35 kilometers, flowing underground through caverns no human has fully explored. The river simply vanishes at a point called the Sumidero, where whirlpools mark water, descending into subterranean passages. For 35 kilometers, the river exists in darkness, carving ever deeper into limestone, creating chambers that may rival the world's largest caves. The river reemerges near the Atlantic coast, bursting from cliff faces in springs that seem to come from nowhere. The underground passage has created unique ecosystems: blind fish that navigate by pressure waves, albino crustaceans that have never known sunlight, bacteria that derive energy from chemical reactions rather than photosynthesis. The caves breathe with the river's flow, air pressure changing as water levels rise and fall, creating winds that howl from cave entrances. Local legends speak of creatures living in these underground waters, stories that might reflect cultural memories of megafauna that sheltered in caves during ice ages. Hydrologists have tried mapping the underground course using dyes and tracers, but the river's path remains largely mysterious, a secret geography hidden beneath the visible landscape. Chile's Marble Cathedral weighs an estimated 5 billion tons, a peninsula and islands of solid marble sculpted by 6,000 years of wave action into forms that challenge comprehension. The marble here isn't white, but swirled with minerals that create patterns resembling frozen smoke, each surface unique, unrepeatable. Waves have carved chambers, arches, and columns that accidentally achieve architectural perfection, spaces that acoustic engineers say rival concert halls for sound quality. The marble continues underwater, creating submarine caves that divers describe as swimming through solidified clouds. Light entering the caves reflects off the water onto marble ceilings, creating a constantly shifting display of blue luminescence that photographers struggle to capture. The formation's weight is slowly causing it to sink, imperceptibly but measurably, adding urgency to its beauty. Minerals in the marble make it slightly soluble, meaning the caves are both carved by mechanical wave action and dissolved by chemical processes. Each year brings subtle changes. A new opening here, a collapsed arch there, the marble cathedral rebuilding itself continuously. The indigenous Tehuelche people held ceremonies here, their songs echoing in chambers that amplify and purify sound. The Patagonian ice dragon manifests when katabatic winds from glaciers meet humid ocean air, creating horizontal tornadoes that seem to violate physics. These phenomena, witnessed rarely and photographed even less, occur when supercooled air cascading down from ice fields encounters warmer, moisture-laden air from the sea. The collision creates rotating vortices that travel parallel to the ground, spinning tubes of cloud that can extend for kilometers. Unlike vertical tornadoes, ice dragons move slowly, almost lazily, their rotation visible as they consume cloud and emit ice crystals. The indigenous name for these phenomena translates to breath of sleeping mountains, reflecting belief that mountains exhale cold air that becomes visible under certain conditions. Pilots avoid areas where ice dragons form, reporting instrument failures and severe turbulence within the rotating clouds. The dragons leave physical evidence: strips of vegetation bent horizontally, ice crystals deposited in perfect spirals, pressure variations that cause eardrums to pop. Scientists studying these phenomena struggle with measurement, as instruments often fail in the extreme conditions that create ice dragons. Each occurrence seems unique, following no predictable pattern beyond the basic requirement of cold air meeting warm. Estancia Valle Chacabuco underwent one of history's largest conservation transformations, converting from sheep ranch to national park across 173,000 hectares. This required removing 25,000 sheep and 500 kilometers of fence, undoing a century of agricultural modification. The fence removal alone took years. Wire that once divided the landscape into manageable parcels, now allowing wildlife to move freely for the first time in generations. As sheep disappeared, native grasses returned, species that had survived in fence corners and cliff edges spreading across valleys. Guanacos, reduced to small populations in remote areas, began recolonizing their ancestral territories, their numbers increasing from hundreds to thousands. The estancia's buildings were preserved but repurposed, shearing sheds becoming visitor centers, worker quarters transformed to researcher housing. The transformation revealed how quickly nature reclaims modified landscapes. Within 5 years, trails used by sheep for decades began disappearing under vegetation. Pumas, following the guanacos, established territories in valleys they hadn't hunted for a century. The project demonstrated that even extensively modified landscapes retain recovery potential. That given opportunity, Patagonia's ecology reasserts itself with surprising vigor. The submarine plateau off Patagonia supports giant kelp forests that reach 60 meters toward the surface, creating underwater structures visible from space as dark patches in the ocean. These kelp, Macrocystis porifera, grow faster than any other marine organism, adding up to half a meter daily under optimal conditions. Each plant anchors to the rocky bottom with a holdfast that can grip with tons of force, necessary to resist currents and storm waves. The kelp creates three-dimensional habitat, as complex as terrestrial rainforests, supporting hundreds of species that couldn't exist without this structure. From above, the kelp forests appear as dark shadows moving with currents, their boundaries shifting with seasons and storms. The forests modify their environment, slowing currents, trapping sediments, creating calm waters where juvenile fish shelter. Sea otters once kept urchin populations in check, preventing overgrazing of kelp, but their elimination led to urchin barrens, where kelp disappeared entirely. Some kelp forests are returning, as urchin diseases reduce their numbers. demonstrating the complex balance required for these submarine forests to thrive. During storms, tons of kelp wash ashore, creating beach wrack that supports entire terrestrial ecosystems. Radio telescopes detect Patagonian glaciers responding to ocean tides 100 kilometers away, the ice lifting and settling in response to gravitational forces transmitted through solid rock. This glacial breathing happens on timescales of hours, movements of millimeters that accumulate into meaningful displacement. The tidal response indicates that glaciers aren't simply frozen rivers, but complex systems connected to their environment in unexpected ways. Water at glacier bases, kept liquid by pressure and geothermal heat, transmits tidal forces inland, creating waves that travel through ice at speeds that vary with temperature and pressure. These tidal influences affect glacier flow rates, crevasse formation, and potentially triggering calving events when tidal and other stresses combine. The discovery that glaciers feel ocean tides revolutionized understanding of ice dynamics, suggesting connections between seemingly separate systems. Seismic sensors detect these movements as continuous background noise, a planetary heartbeat of ice responding to lunar and solar gravity. The implications extend beyond Patagonia. If glaciers here respond to tides, similar processes likely occur in Greenland and Antarctica, affecting predictions of sea level rise. The southernmost grove of Antarctic beech trees clings to existence at 55 degrees 31 minutes south on Isla Hornos, marking the absolute end of tree growth toward Antarctica. These trees, Nothofagus antarctica, exist here through biological determination that defies reasonable expectation. They grow prostrate, never achieving heights greater than a meter, spreading horizontally like desperate wooden hands grasping at soil. Their wood is so dense from slow growth that it barely floats. Annual rings so tight they require microscopes to count. The trees reproduce more through layering, branches touching soil and rooting, than through seeds, which rarely mature in the brief growing season. This grove exists in conditions where a few hundred meters further south, or a few meters higher in elevation, would mean death. The trees have survived here since the last ice age, genetic analysis showing they've been isolated for 10,000 years. Beyond this grove extends the Drake Passage and then Antarctica, making these trees the final wooden sentinels before the frozen continent. Their leaves, adapted to maximize photosynthesis in weak light, continue the process even under snow, extracting energy from light that filters through. As we drift away from Patagonia's vast expanses, we leave behind a land that exists in perpetual conversation with extremes. We've traced the edges of ice fields that remember snowfalls from before human memory, followed rivers that seem uncertain which ocean deserves their waters. We've stood at the boundaries where forests surrender to wind, where continents thin themselves to islands, where the possible gradually becomes the impossible. Through these 100 moments of geographical contemplation, we've witnessed how Patagonia refuses the comfort of middle ground. Here, winds don't simply blow, but sculpt. Glaciers don't merely melt, but calve in explosions that echo across valleys, and distances aren't just far, but transformative to those who traverse them. We've seen places where Earth reveals its patience, in stones 2 billion years old, in whale families returning to the same bays for 40 generations, in trees that add a millimeter to their width each year, yet persist for centuries. Patagonia reminds us that geography is not static, but a continuous negotiation between forces we can barely comprehend. The patient advance of ice meeting the stubborn resistance of granite, the persistence of wind gradually relocating entire landscapes grain by grain, the slow surrender of stone to root and rain. It is a place where human presence feels temporary, where our maps and measurements seem almost presumptuous against such sublime indifference to our scale of time and comfort. The stories held in these landscapes, from hand stencils in caves to anchor scars on coastal rocks, from Welsh tea houses in the desert to railways slowly being buried by sand, speak to humanity's persistent attempt to inhabit the uninhabitable, to find meaning in vastness, to create home where home seems impossible. Yet Patagonia ultimately belongs to forces larger than human ambition, to the condor circling on thermals we cannot see, to the guanaco following paths worn by countless generations, to the southern beech forest advancing and retreating with climate's slow breathing. Perhaps what Patagonia teaches us in these quiet hours between waking and sleeping is that Earth keeps its own counsel, shapes itself according to laws older than memory, and that there are still places where distance means something profound, where silence isn't the absence of sound, but the presence of wind and ice and stone conducting their ancient conversation, where beauty doesn't comfort but challenges, demanding we expand our definition of what a landscape can be. As sleep approaches, know that somewhere at the far end of the world, Perito Moreno continues its delicate balance between advance and retreat. The wind continues sculpting stones into impossible forms, and glaciers advance through darkness toward seas that await them with infinite patience. The Tehuelche paths still cross the steppe, visible to those who know how to look, even though the footsteps that made them have been silent for generations. The marble caves continue their 6,000-year sculpture project, each wave removing a few more atoms, changing the cathedral imperceptibly but inevitably. Tomorrow, Patagonia will be slightly different than today. A few tons of ice will have returned to the sea. A few million grains of sand will have traveled east. A handful of seeds will have found unlikely purchase in cracks where soil barely exists. This constant change within apparent permanence, this dynamism within seeming desolation, reminds us that even the most austere landscapes pulse with invisible life and motion. Rest now, carrying with you the knowledge that there are still places on our planet where nature operates without reference to human time, where geology's patience makes our urgency seem quaint, where the horizon extends so far that you can see tomorrow arriving from a great distance. Sleep well, knowing that Patagonia continues its slow dance of ice and stone, wind and water, creating and destroying and creating again, indifferent to our watching but generous enough to let us witness its terrible and perfect beauty. The geography of Patagonia will be there when you wake, changed in ways too small to notice but too numerous to count, continuing its conversation with eternity in a language we're only beginning to understand.